Okay, for this tutorial, I would like to use a gear component that Daniel Piker made to simulate a gear like this. And it says in the description of the Grasshopper page that the gear component is included in the latest release of Kangaroo, which in this date he's talking about the Kangaroo 1. So if I look at the Kangaroo 1, there is a gear component here. Now I'm opening this gear component in Rhino 6, and this component has a bit of problem itself, and it's not working properly. So I tweaked the source that I found on the web and changed it a little bit to work it properly as it should, and I uploaded the code source code on this gist, and you can copy paste the script from this page, and I attached the URL to the video description so you can use that. So let's try to make a gear. Well, first of all, let's start with a circle, maybe a radius of 10, probably, could be anything. And let's divide the curve by a even number. So could be any numbers here, but I want to make sure that this even number, so I'm gonna add a module here by 2 and add it with the base number here. So even if I use the odd number, it becomes the even number here. Okay, then after that, let's use a dispatch, and here make a line between A and B, and then you will have a line like this, skipping one line ahead and having a line like this checker mark. Okay, and let's get a vector. So you want to move this curve to the outside, so what you can do, maybe you can get a vector of each curve, each line, and rotate this vector. Rotate vector using z-axis with the minus 0.5, which means minus 90 degrees, and use that vector to actually move the curve, move the line. So I'll amplitude this, and I want to set a parameter how much you want to move this curve. So I don't know, maybe maximum 10, and attach to here, move the line. Okay, I think it's too much. Yeah, something like this. And let's scale this curve a little bit smaller, and this one to be bigger, so that it will be looking like a real gear. I'm not really sure how the real gear looks like, but I suppose it looks like that. So let's use the scale for this curve first. I want to first get the middle point of this line, so I'm gonna use the evaluate lengths and put 0.5 here and scale by the middle point. What I want to scale is the line, and let's set the parameter for the scale value to the F, and if I make it smaller, this part will be smaller, and I want to make this one to be larger when it gets smaller, since I want to set the lengths of this one and this one to be around the same size, about the same size. So what I can do, I can add the value for the scaling up by calculating these scaling down value, 1 divided by scaling down value, and I can use the same scale, and this time scale this curve. So I will attach the curve component here, and I also need a middle point for this curve, so attach here and attach here. Okay. Now let's hide these for now, and I have those, and I want to have the curve that connects this line and this line, so let's get the end point for each line. End point for each line, and make a line connection here and here. Okay, and I also want a curve here, so let's make that as well. What I can do, I think from this one, maybe I can shift this bottom curve list and get the end point again, and make a line between the end point with the first one and the starting point with the second listed shifted curve, and I get this line. Okay, so let's hide the unnecessary ones. Okay, now this one looks like a gear, so let's merge this all together. Something like this, and I want to make it as a closed polyline in order to use it for the gear component. So join it to make a closed curve, flatten this and join curve, and now it looks like a curve, like a gear. Maybe I would like to have a circle as a design. Doesn't really do here, doesn't really do nothing here, so but well, just to make sure it looks like a gear. So I don't know, maybe I can use this parameter, the radius of the circle, to define the radius of the inner circle. Maybe I can divide it by, I don't know, 3. Okay, it's fine. And let's move it here. Okay, now next one, Next one I would like to have is the let's change this parameter so that right now the gear point, how do I say, the one of the edge of the gear is pointing toward the angle direction. It's not on the x-axis, so I want to fix that to make it easy to orient it with the other gear. So what I would like to do is to rotate this whole gear a little bit. And how much should I rotate is that you can get it from, now the total number of points is 16, so you have 2 pi, which means 360 degrees. You divide the 360 degrees by the number of points and you'll get the value that you want to use for the rotation. I think let's bring this number, or maybe I might need to multiply by 0.5 if I use this here. Yeah, I think I need to divide by 2. Yeah, okay, looks good. And the other one, I can use the negative value here. Okay, and I can move this to the right, to the x direction for initial position. So how much should I move? First of all, the diameter of the circle, so I should bring this parameter here and multiply it by 2, which is because this is the radius. Okay, and I also need to move by the value of the offsetted gear lengths, which is this one, I think. So let's put the num here. And do I need to multiply this? I'm not sure. Let's first add it to see how it looks like, and yeah, it's almost touching. And I would like to make a little bit of offset here to the right so that it wouldn't touch it as an initial position, so I will make a offset parameter. I don't know, something like 2, and add with the value here and use that to move the gear. Maybe 2 is too much. Maybe around here. Yeah, looks good. And I also want to move the circle, which I don't really care much. Yeah, I'll just move this here. And yeah, okay. Now I have set the initial position. Now let's use the gear component. First, I'm gonna use the gear component provided in the Kangaroo component, Kangaroo plugin, which doesn't work properly. I'll show you how it doesn't work first of all, and I'll show you how you can fix that later on. Okay, now the D is the initial input, which you'll move by yourself. So I'm gonna make a rotation for the left hand side gear, maybe using the radians, and make a slider for controlling the angle like this. Let's hide this. So what I would like to get as a result is that if I rotate this gear, this right hand side gear would rotate as it follows the collision of the first gear, collision between the first gear and the second gear, using the collision to rotate this one, so I don't need to control this by myself, but I automatically rotate by itself. So I will input this one, the left hand side, to the D, and F is the follower, so this one will be the one. I'll put it to 0. And A is the axis, the center of the rotation of the followers, which is around here. So let's get that. I could just use the construct point and use this value in the X, and I get the center point for the second gear, so I'll put it in the A. And now I don't need the C and P, just need to set the button on the R so that I can reset the simulated geometry. Now let's hide this. And the result you'll get from the F is the rotated curve, the gear simulated curve. Now let's try that. If I remove this, you see that it's not working correctly. Somehow it's touching the gear, both gear, the left hand and right gear is touching together, and it doesn't look like the movement of the gear. It's intersecting. Let's reset this. So the component doesn't work properly. So as I said in the introduction, I have checked the source code of this gear component and tweaked a little bit for Rhino 6. Maybe it should work for Rhino 5 as well. And I put it on this gist as a script. So I will just copy this and put it on the C# component to see if it works. Now, first of all, what I need to copy is this part. Okay, until here. Inside here. Okay, that's okay. And I also need to copy one more thing, is this one. Okay, copy here and paste it here. Now you also need to set the input and an output name for here. So let's check the name. So it's DFIAXCI. Well, it's kind of almost the same as this one. But you cannot use the same input and output name, so for that I'm renaming it to something different. So this one is FI, and the third one is AX, and the fourth one is CI, and the fifth one is P, And the last one is R. Okay, and for the output, the first one is CO, and the second one is AO. Now I need to set the types. So the first one is the list of curves. So set it to list of curves, and the second one is the item curve. Third one is item point 3D. Fourth one is, what was it? List of curves. List of curve. And last two parameters are boolean item. Okay, and it still have an error. Let's see what's wrong. Okay, it's said in Japanese. FO doesn't exist in this context. Really? Did I made a mistake? Oh yeah, I need to have a FO. Yeah, I didn't have FO here. And for the third one is AN. Okay. Let's press OK, and object is referencing, it's not referencing as an instance. 84. Okay. I guess I need to input a geometry. Okay, so the input itself is same as this one. The first one is the manually rotating curve, rotating gear, and the FI is the following curve, and the axis is AX. And I also need to put the button here. Okay, now let's hide this one and let's show the curve here, and it's not showing. Okay, if I press the button it shows. Okay, let's see how it goes if I rotate this. And it works. Yeah, the gear is working nicely. Now I'm gonna tell you which part was different from the original one. Is here. The curve orientation clockwise, counterclockwise. I mean, the original source code was written as -1, and I think it's because of the maybe it's the Rhino 5, based on the Rhino 5 Rhino Common SDK, and I guess Rhino 6 has different API for this one. So I just renamed this, rewrote this like this, and it started working. So I guess this is the way to work. Yeah, it's working correct. Good. Let's just make a simple animation using a timer. Make it to 20 millisecond, and let's have a counter. What is this? Circle. Well, I'll put it here. Let's make it like a 3D, shall we? It will be... Okay, wait a minute. Yeah, let's make a 3D. So I don't need this one, so I'll delete this. And let's merge this one together and make a boundary. So flatten it and boundary and extrude to something like 4. Okay. And this one as well. Merge it. Flatten it. And use the same operation. Okay. And let's color this. The first one to be, I don't know, red. And the second one to be blue. Okay. It's like a magnet. Okay, and let's check. Yeah, it's working. Now let's use the timer, put this timer to the counter and put the boolean to the reset. And let's multiply the counter by maybe something 2 and put it on the radians and start. Okay, maybe I can make it faster, like 10. Oops, too fast. And that's it. That's how you can simulate the gear. It's pretty simple. You just, the thing that you just need to do is to replace the original gear component from the Grasshopper, from the Kangaroo plugin to the tweaked script. I guess it's only for the Rhino 6, I'm not really sure. I haven't tested on the Rhino 5. But that's it. Thank you.